Now we'll look at the second part of the supervised learning, which is regression. So in order to do regression, we need to have a data set where the target is a continuous value. So to have a continuous variable, let's import the load Boston dataset. In the Boston dataset, we have the features of house and the price of that house. So the target is the price of that house, and the features are the features of the house. The X is the feature of the house. So let's see what are the keys we have in the bunch type of object. So the keys we have is data, target, feature names, and file name, and now all those stuff. So using the data from the Boston data that we have loaded here, so we'll pass it in the data parameter, and as the columns we'll pass the Boston data and the feature names. So here we can have all the feature values. So here you can see all the feature values, but we do not have the price, which is the target. So in order to add that, we can use a function, a data frame method that which is assign, where you can pass the column name. Here the column name is price, and you can pass the corresponding array with it. So the array is in the list is in Boston data, and where you use key as the target as the key. So let's look at the data set. Let's look at the data frame now. So let's see how it looks. So here you can see we have price, which is a continuous variable. So after looking at the price, you can see whether there are any null values or not. But this step is data pre-processing is a must step when you create a data set on your own. So after looking at that, we can split it for, as you have looked in the machine learning pipeline. Splitting must be done before training the model, so that we have some data for training and some data for testing, which can be used to evaluate our model. So here you can see we have splitted the data into training and testing. So here in xtrain, I've told about all these functions, so I won't go into these functions again. So let's split it, and after splitting it, we'll choose the algorithm that we'll be using, which is linear regression. And how do linear regression works? uh, so linear regression works like, it randomly draws a line, then it calculates the distance from the line and the sample points, that is called the error. So it calculates all the distance, the square that is called the square error. So it calculates all the distance from the sample points, from the original sample points to the line, and after calculating the distance, it adds up all the distance, and that is called the square error, least square error. So after calculating the error, it tries to minimize the error by shifting this line and changing the bias and the weight. So it tries to draw the best fitted line across this sample, where the distance from the sample points and the line will be minimized, so that as a result the cost will be minimized. So that's the idea behind linear regression. So in order to use linear regression, what you have to do is, from sklearn.linear model, you can import the linear regression class, and using the linear regression class, you can create an object, and with that object, you can use the fit method, where you have to pass the xtrain and the ytrain. Xtrain contains all the features of the house, and the ytrain contains the corresponding prices of the house. So let's see how our model works. After doing that, the model is trained. Let's see the score of the model using the testing data. Here we can see it again. Let's see the training accuracy and the testing accuracy. Here you can see the training accuracy is 0.72. So the model, so we have a cost of like of 28%. Like we have an error rate of 28% that you can see. And if we look at the testing accuracy, we have a testing accuracy of 78%. So let's look at our predictions. So here you can see these are the predicted price values. So these are the predicted price values, and after looking at the predictions, you can also see the coefficient of the function and the intercept. And what intuition do we gain by looking at this equation? So I want to give you some intuition about linear regression, which is that here you can see we have certain features of the house. So each feature has some effect on the price. So to calculate the amount of effect it has on the price, we introduce a new coefficient along with the feature, which is called weight. So if this cream feature has more effect on the price, then we assign it with a higher weight. And by weight, I mean this coefficient that I added here. Here you can see we have 13 features for the house, and I have added one parameter with every coefficient, and this parameter can be called as weight, which denotes how this feature affects the price of the house. And this parameters are changed every time while when we calculate the cost by using the distance of the sample point and the line, the distance between the sample point and the line. And we also have a y-intercept. So this is the function that your algorithm, that your linear algorithm has generated to calculate the prediction. To when you give it a 13 feature, when you give your algorithm a 13 feature, it can calculate the y hat, which is the predicted value, and you can compare your predicted value with the true value. If you want to use another regression model, you can use ridge regression. What ridge regression does is it adds an L2 regularization effect. So what do I mean by L2 regularization effect? It means that you add a small amount of bias to get a drop in variance. And what do I mean by that? It means, for instance, if you have a training data like this, and your model drew a line passing through all these points, passing through all these points. So here you can see that our model overfits on all these points. So there is no, the cost is zero. So the accuracy is 100%. When you get an accuracy of 100%, you might be excited, but you shouldn't be excited, because there might be a case of overfitting. So your training data is this pink color points, and you have a testing set where the points are not on the line. So here you can see it has a good accuracy on the training set, but it does not have a very good accuracy on the testing set, because there is some distance between the points and the line. So this distance is called the error. So there is some error. So what your ridge regression does is it adds some biasness to this line. So it does not go through all these points. It shifts here, like for example, you add some biasness so your line looks like this. So if it looks like this, then you can see that the distance is reduced, error distance is reduced between the points and your line. So this what ridge regression does. And let's see if it improves the model. After fitting it, we'll evaluate the model. Let's see what's the accuracy we get. So we see that there is not much improvement in this model. So this data set, but it works really well sometimes. And for this data set, it unfortunately doesn't work as well. So here you can see it has generated some coefficient, 13 coefficient for 13 features and one bias. So you get the idea how the equation will be, what equation the ridge regression model has generated. And I want to give you another algorithm in your toolkit, in your box of machine learning toolkit, that is logistic regression. So logistic regression is very powerful and it is very easy to understand. And all the machine learning courses start with logistic regression. And despite of its name, I don't want you to get confused because this logistic regression is used for classification problem. It's not used for regression. So I have it in the regression category, but and the name also looks like logistic regression, but it is not used for regression. It is used for classification. So since logistic regression is used for classification, will since and this dataset is made for regression, we'll tackle this problem using classification. So we'll change the dataset in such a way so that it can be used for classification problem using logistic regression. I won't go into the details of logistic regression, but to give you some intuition, I'll say that, for example, on this axis we have size of the house, and in this axis we have the price. The price can be high. The price has two classes, high and low. So from this logistic regression fits a S-shaped graph. So from this graph you can see that if you have a size of the house where the size of the house is very low, you get the price, it is classified as low. And if the size of the house is a lot, then the price is high. And if the size of the house is somewhere close to like zero, like it won't be zero, like somewhere like only one, the size is very close to zero, then you can see it has a value close to 50% or 60% like that. So that's the idea behind logistic regression. So let's see how you can tackle this problem of, since this data set is made for regression, how we can make it how we can make this data set work for classification problems. So let's see. So here you can if you run this boston df.describe method, so here you can see the price column. So if we just want to see the price column, take only the price. So here you can see that the price column has um, a mean value of a median of 21, and it has a mean of 22, and then you can see there's a max value of 50 and so on and so forth. And after that, what you can do is you can create a bean. So here you can see that I've created a bean. By bean, what do I mean is that using this cut method, using this cut function from the pandas module, you are cutting a part from the data frame, from the post data frame, and you have created a bean. So the what do I mean by bean is that wherever the price is between 4 and 21, it is labeled as low. It will be transformed and labeled as low, and wherever the price will be in between 21 and 51, it will be labeled as high. So let's see. We don't need this column here. We don't need that cell. So let's see how it looks. So here you can see previously we had the data set looked the data set looked like this with all the price values, and now since we have transformed it, now we can use this for a classification problem. So in order to do that, how can we do it? So here you can see we have to use the label encoder. Why do we have to use the label encoder? Since this price is in the form of strings and our machine do not understand string values, so it only understands numeric values, and the cost function and all the algorithms need numeric values to do all the calculations. They cannot work with string. So what we'll do is from sklearn.pperson we'll import the level encoder class, and after importing the level encoder class we'll create an object called enc, and using enc.fit transform fit transform will encode it, and after encoding it, let's look at the data frame. So here you can see wherever there is high, it is labeled as 0, wherever there is low, it is labeled as 1, and so on and so forth. You can get the idea what it did. And after labeling it, you can take all the features in the x variable and all the target in the y variable. Then you can create a train and test set using train test split, and after doing that you can fit the logistic regression. To fit the logistic regression, firstly I will use the default iteration. So let's see what's the default iteration. Here you can see there is a convergence error. Here you can see we get a convergence error because the model has not converged yet. How did it understand that the model did? How did it understand that the model did not converge yet? It is because the error is varying noticeably. So since the error values are large between iterations, so you can say that the model did not converge. So in order to make the model converge, so for the cost function minimum, we'll use a maximum iteration of 1000. Let's see. You can still see the model did not converge, so I'll use 10,000. Here you can see the model did converge. After the model converge and we have a minimum error, we'll check the score. So here you can see we have a training accuracy of 89% and a testing accuracy of 83. You can also increase the number of iteration, and let's see if the model works even better. Now the model does not work better. So we can, after doing that, we can see the confusion matrix, and here you can see we have 9 misclassification, and here we have 12 misclassifications. So this is how you can transform the dataset made for regression into a classification dataset. Or if you want to have more classes, then you need to create more bin ranges. Like you have to, if you have 3 classes here, then you have to place 4 bins value. Like it determines the range. So that's it from the supervised learning domain, and next we will see the unsupervised learning using scikit-learn.